This conference will now be recorded.
That's a little delayed. Before we get started, I'll say good afternoon, everyone, and welcome to the August sector-specific Drought Early Warning Outlook, our Southern California pilot. Before we get started, I want to say thanks everyone for joining after a little short midsummer hiatus. Our plan is to continue to do these through August, September, and through the water year 2026. Before I hand it over to Andy, I did want to mention that the plan going forward is very similar to what we've been doing. The only difference at this point is between last year and this year is we're planning to modify the written document a bit that comes with these. So every Friday after the Outlook, you get an email with the key points, the recording, and a short write-up. We are working to simplify and shorten that write-up, so that might look a little bit different when you get that tomorrow. Obviously going to this year, we've learned a lot. We've got a lot more experience and hopefully a better sense of what information you may need. But I do want to emphasize we are still really hoping that today, tomorrow, anytime throughout the season, we still would love to hear from you, hear what questions you have, what information needs you have, feedback on the content of the scenarios, and really continue to help us help you essentially. And with that, I'll go ahead and pass it over to Andy for any starting comments in the Outlook.
Yeah, thank you very much, Amanda. And yeah, thanks for the good introduction. Yeah, we're starting our second year of this process of modernizing drought early warning. And last year, we provided a lot of information regarding La Nina, and a lot of our worst fears had happened, and we had a lot of downstream impacts. And unfortunately, where we are this year is a little bit more of the same. So today's August 28th, and I'll continue with the Southern California sector-specific drought outlook. I just wanted to outline this very quickly about what our effort is here about modernizing drought early warning and really creating drought resilience for the nation's economic sectors. Obviously, we're starting here in Southern California in 3 sectors, but we're hoping to scale this to a level that does cover a larger area across the United States. And our mission here is to inform early warning decision making based on co-developed sector-specific and evidence-based drought intelligence. Co-developed is important to us. We would love to work with you all in order to be able to put something together that's meaningful and can help you make decisions. And we're going through this process here of delivering monthly sector-specific drought scenarios based on our integrated and tailored monitoring and forecast information. In our modernizing drought early warning effort, we are continuing to focus on agriculture, water utilities, and public health sectors in Southern California. And the counties that we're covering here are outlined in black in Southern California. Now, the timeline this year will be similar to that of what we did last year. So we'll begin here in August. We'll have a briefing at the end of September, the end of October. And then because of the holidays at the end of November and December, we'll just have one briefing consolidated toward the middle of the month in December. And then finally, reviving the normal cadence of monthly briefings at the end of each month. That's the end of January, February. And we'll do March and April and so on and so forth. We just didn't indicate those here because we ran out of columns on the slide. Now, we're always soliciting feedback, and as Amanda said, just trying to solicit that feedback, whether that's here or whether that is after the fact. So what questions do you have about drought? What topics are you considering regarding drought and its cascading effects? So as I go through the presentation here, I'll stop periodically to ask questions and whether they're comments. And folks can speak verbally or they can type in the chat box here, which I can see here on the right. And Ken has already wrote here and said hello to us, so thank you very much. All right, in our sector-specific drought briefing here, we'll begin with a global perspective about global conditions that are relevant to Southern California's sectors, then move into a regional perspective with Southwest conditions that are relevant to our sectors, and then finally getting into the sector-specific drought outlook, beginning with water utilities, moving into public health, and then finally agriculture. We have many lines of evidence here. We use observed conditions, and these are as of this morning, August 28th at 10 a.m., unless indicated otherwise. We're using predictions and end of season outcomes. So predictions are expert interpretation of many types of forecasts to help anticipate the future. And then finally, with end of season outcomes, combination of season to date observations and similar historical periods to forecast the chances of a certain outcome. In the scenarios that we will provide, we also indicate our confidence: high confidence, medium confidence, and low confidence. And they're just what you would imagine. High confidence, we've got close agreement among several robust sources of evidence. And low confidence, the opposite of that. Very little agreement among our sources of evidence. Now, I'll move into the global perspective now. And at the end of each section, the end of this one too, what I'll do is I will open it up to questions and comments. So the El Nino Southern Oscillation, we hear about it a lot. And yes, indeed, it does play a very big role, and that's why we focus on it here. So the El Nino Southern Oscillation, it's composed of three phases: El Nino, La Nina, neutral, and it's related to weather anomalies that are used to predict conditions in California many months following. Our second point here is that La Nina is forecast to develop in late 2025 and persist into early 2026, which increases the chances for below average precipitation in Southern California. So you can see where we're going with the outlook already. Now, we care about the El Nino Southern Oscillation because it has wide-ranging impacts across the globe. I mean, very simply, the El Nino Southern Oscillation is just the variations in winds and sea surface temperatures in the tropical Pacific Ocean. Those variations actually produce a lot of energy and energy release in the tropics. And that's almost analogous to dropping a massive boulder in the tropics and watching the waves emanate away. So here in Labor Day weekend, maybe you'll go to a lake and you drop a big boulder in and you'll see waves that move away from where you've dropped that boulder. Very similar in this sense, where we have these waves that move away in our atmosphere, and they set up in such a way over North America that they lead to very persistent anomalies. And as you can see here, related to La Nina, we get these preferential patterns of wet and dry conditions over North America during a typical La Nina winter. So in the Pacific Northwest, we tend to see wetter conditions. The same goes for the Ohio Valley and the Great Lakes region. But unfortunately, in the southern tier of the United States, extending from the southwest all the way into the southeast, we tend to see drier conditions, and we also tend to see warmer conditions as well. And that right there is the most likely situation as we go into the Northern Hemisphere winter, and of course for Southern California moving forward. Now, there are many different ways to measure the El Nino Southern Oscillation. The El Nino Southern Oscillation can be measured by changes in winds, by sea level pressure in the tropics, and also by sea surface temperature anomalies. And that's actually what you're seeing here. Several different indices that are based on sea surface temperature anomalies are used. And one index that is used more and more often just to account for warming oceans is a relative El Nino Southern Oscillation Index, which is essentially taking the Nino 3.4 index, which is sea surface temperature anomalies over the tropical Central Pacific Ocean, and scaling those sea surface temperature anomalies based on sea surface temperature anomalies across the tropical oceans and accounting for warming generally across that area. Now, this is what the time series of that index looks like dating back to 1950, and it's pretty smooth. You can see here El Nino and La Nina events periodically through time. And just noting here the 2024 25 La Nina event that showed up last year. So this event right here, when viewed through the lens of this relative index, was actually fairly moderate in the historical record. And this is what we are anticipating for this coming year. Now, in terms of the forecast, this is exactly what's being shown here. So this is forecast relative ENSO index that I showed previously over the coming months. And these are for several different forecast models. What we're seeing here is for these forecast models to overwhelmingly indicate a La Nina event later in this calendar year and early into the next calendar year, with a magnitude that's actually pretty substantial. And as a result of that, indicating here that La Nina, and a pretty moderate one for that matter, is the most likely outcome. Now, our colleagues at the NOAA Climate Prediction Center monitor El Nino Southern Oscillation very closely, and they make forecasts. And this is one such forecast here. What this shows is the probability of La Nina, ENSO neutral, and El Nino for several subsequent 3-month seasons, beginning in July, August, September, October, all the way out there to March, April, May. And as you can see, as we move through later in this calendar year and early into the next calendar year, that the likelihood of a La Nina event becomes the most likely outcome for the El Nino Southern Oscillation. You may wonder here on this curve, what do these blue and red and gray lines mean? Well, they actually mean how often an El Nino or La Nina or ensoneutral event happens. So by the time we reach later in the calendar year, October, November, December, we tend to have a La Nina event about 35% of the time. So the forecast probabilities of being over 50%, 57% in the forecast amounts to about a doubling of the chances of a La Nina event, which is why we are weighting our perspective so heavily on La Nina later in this year. Now, I'm going to finish up right. I'll open it up to questions if there are any questions about La Nina and potentially what its effect on Southwest hydroclimate and drought may be. Okay, well, hearing none, I will move on here to the regional perspective. So basically, conditions in the Southwest United States and Southern California that are related to the current drought. Well, unfortunately, drought continues across Southern California and the Southwest United States and has been there for some time now. The second point here is that for the period of September 1st to August 22nd, just nearly a year or a week shy of a year, it was the third driest and ninth warmest such period in Southern California since 1951. And then finally, above average number of extremely hot days were observed in southeastern California during June to August of this year, 2025. So on this slide, what's being shown is the US Drought Monitor in the top panel here. So the Drought Monitor, it considers several different types of drought and its impacts, and it's produced by humans that look at all drought conditions in aggregate and look at several different lines of evidence and then assign drought categories here to the United States. And this snapshot here happens to be for the Southwest. So drought is characterized by moderate drought, severe drought, extreme drought, and exceptional drought indicated by these colors, and abnormally dry conditions. Well, over the counties that we're considering here in our Southern California pilot, area in drought is about 92%, just a little bit shy. And that includes D1 through D4. So there's quite a bit of drought in the region, and this has been quite persistent for some time now. So this time series here shows the total percent land area of our Southern California region from 2000 all the way to the present. And as you can see here, that drought has overspread and persisted across the region since late last year, 2024, and has been at times rather intense. Now, the reason for this is because it's been so dry over the last 2 months. On the left, this is the precipitation percent of average for the 1st of September to the 22nd of August. And on the right, this is the maximum temperature departure from average. So on the left, it's a fraction of average compared to 1991 to 2010. That's shown as a percent. And on the right, that's shown in degrees Celsius. So as you can see, overall of Southern California, precipitation was below 50% of average. It was between 25 and 50% of average across almost all the counties that we are considering here. On the right, this is the maximum temperature departure from average. And as you can see across almost the entirety of the region, with the exception of coastal areas in Santa Barbara County, Ventura County, Los Angeles County, temperatures were above average. Thankfully for these areas, there was a fair bit of onshore flow during this year, this summer, and also in the prior spring, which led to below average temperatures. Now, if we're to consider all these together, this scatter diagram shows the maximum temperature versus precipitation for the period of September 1st to the 22nd of August. And noting here that during 2024 and 2025, what we found here is that precipitation was the third lowest, so the third driest such season, and temperatures were the ninth warmest such period in Southern California. So when it compares to a historical record, this season was extreme in the context of conditions since 1951. And temperatures over the last few months have been very warm and anomalously so over southeastern California. So you can see here in these easternmost counties that we're considering that we had about a week and a half, almost 2 weeks more temperatures greater than 37 degrees Celsius. And that amounts to about 98.6 degrees Fahrenheit, which is body temperature here. Over other areas, thankfully, those areas that were affected by this onshore flow, which kept these temperatures down, we actually saw fewer 37 degrees Celsius days, really hot days, compared to what we saw in the past historical record. So if there is one silver lining here, it was the reduction in the extreme heat days further to the west of our region of focus. Now, getting into the forecasts relevant to drought, these are really based on conditions that are forecast by our colleagues at the NOAA Climate Prediction Center. The first point here is that drought is expected to persist through at least the end of November of 2025, and this again is according to our colleagues at the Climate Prediction Center. 2, above average temperatures are forecast in the southwest US during autumn, that's September to November of 2025, winter, December to February of 2026, and spring, March to May of 2026. And then finally, below average precipitation is forecast in the southwest US during winter and spring, both of 2026. So we begin here with the seasonal drought outlook. So this is for a period beginning on August 21st and then going through the end of November. That's November 30th of 2025. This brown color here indicates where drought is most likely to persist, and drought persistence is anticipated almost throughout the entire southwest United States, and even in the greater western United States as well. You can see here that drought persistence is really from Santa Barbara County all the way down to the southeast throughout the entire state. Now, why is that? Well, the forecast is not favorable for any drought amelioration over the next many months. What's being shown here is September, October, November 2025 precipitation and temperature forecasts. What these show is the probability of experiencing below average conditions, above average conditions, and near normal conditions. So for precipitation, above normal conditions are indicated by the green shading, below normal conditions are indicated by the brown shading, and near normal conditions, which don't appear on the map here, can be indicated by gray shading. Now on the right, this is for temperature. So above average temperature probabilities are indicated by the red coloring, below average temperature probabilities are indicated by the blue coloring, and there is no near normal on here, but if there were, it would show up in gray. Now, over the southwest United States, there's a really big bullseye of below average precipitation probabilities over the 4 corner states, extending a little bit further to the east through Texas, and really through Arkansas, Missouri, and Tennessee. Only a little bit of this area makes its way into Southern California, but in some ways, this is not really Southern California's prime time for precipitation. So in some ways, having a above or below average precipitation forecast isn't really as meaningful as if it was during December, January, February. Meanwhile, above average temperatures are forecast across the southwest United States. Now getting in here to December, January, February, we're getting into prime time for Southern California's wet season. And the forecast on the left looks very similar to that of conditions that we tend to see during La Nina events, as in below average precipitation is preferred in the southwest United States, really the southern tier of the United States moving through Texas into the southeast, whereas above average precipitation is forecast in the Ohio Valley and over Montana, though this part of the country is actually in a dry season, so take this with a grain of salt. On the right here, this is for seasonal temperature outlooks, and above average temperatures are preferred over the southern tier, including that over the southwest. And also moving on here to March, April, May of 2026, below average precipitation is preferred in the southwest US, which includes Southern California, perhaps with the exception of areas like Santa Barbara County and San Luis Obispo County. But meanwhile, above average temperatures are forecast. So that finishes up this regional perspective. Are there any comments or questions before we get into each of the 3 sectors? Okay, well, hearing none, let's move into water utilities here. So the water utility scenario that we're providing here is that reservoir storage and groundwater levels are expected to be lower in June 2026 compared to August 2025. We have high confidence in that. June 2026 tends to be the time of year when reservoir levels reach their maximum level for the year after we've seen our runoff season after snow melt has occurred. And unfortunately, there's evidence to support, and with a high confidence, that reservoir levels will be lower then than they are right now. So the supporting evidence here is that there's an increased chance of below average precipitation and above average temperatures between September 2025 and May of 2026 due to forecast La Nina-like conditions in late 2025 and early 2026. There's increased chances of below average snow water equivalent on April 1st, 2026 due to forecast La Nina-like conditions in late 2025 and early 2026. And then finally, the Bureau of Reclamation projects lower inflows in the next 2 years. So where we typically begin here is by looking at reservoir levels over California. And this is as of yesterday, so August 27th, 2025. Reservoir levels are near average, and yet they've declined compared to last year in Southern California. And this is too bad to see right here. And if you follow this over the last several months, you've seen that conditions we've seen lower reservoir levels. It stands to reason that we've seen that in the dry season here, just because there's water use. But at the same time, we didn't really see that recovery last year because of the really poor precipitation season that we endured. Now, in terms of groundwater, this is as of the 24th of August and indicating really mixed conditions over Southern California. And they have been declining since last year as a result of a really poor precipitation season in 2024 and into 2025. So you're going to see this perspective a lot, so I'll dwell on it for a little bit. So this is for the September to May period. So covering the entirety of the winter wet season in Southern California and the Southwest United States. What this is showing on the left is the chance of below average precipitation related to La Nina compared to the chance of below average precipitation related to non-La Nina. So when you see these brown colors, it means there's an increased likelihood of below average precipitation related to La Nina. And if you saw green colors, and there's a little bit scattered in here, you can see that this indicates a decreased chance of below average precipitation. On the right, this is for temperature, and very much the same way. The red colors indicate an increased likelihood of above average temperatures related to La Nina. The blue colors indicate a decreased likelihood of above average temperatures related to La Nina. Well, this map doesn't look very, these sequence of maps don't look very good. There's a very high likelihood of below average precipitation related to La Nina that's over the Southwest United States. And this extends all the way from Southern California into the Southwest. And it also is true for above average temperatures, where above average temperatures are much more likely related to La Nina than they are for these non-La Nina events. Well, it stands to reason that if below average precipitation and above average temperatures are preferred related to La Nina, then we would have an expectation for lower snowpack in the times that really matter. And in this case, we're looking at April 1st because it's a time of year that people really look at snowpack and its meaningful behavior as it relates to runoff in April, May, and June. So these are for six seasons, 6 of the recent La Nina years that we have. There's 2012, 2018, 2021, 2022, 2023, and 2025. And what you can note here is that overwhelmingly over the Southwest United States, average and below average snowpack and snow water equivalent on the 1st of April is preferred. There is one season that's not like the others. It's the 2022-2023 year, where on April 1st of 2023, there was exceptional snowpack. So despite the fact that La Nina does increase the odds of below average snowpack and snow water equivalent on April 1st, there are times where we can see some outliers. And 2023 was one such season where you can have above average snowpack. Now, this is from the Bureau of Reclamation, and what it indicates is the pool elevation of Lake Powell, and this is on the vertical axis, compared to time. So the black line here is indicating what was observed and noting that beginning in January of 2025 and ending sometime around now, is that there was a decline during the wet season into the spring, an increase after there was snow melt, and then another decline during the dry season. Unfortunately, this resurgence or peak in Lake Powell levels was not very high compared to where it was previously. That's because of the below average precipitation that we saw last year. Now, to the right of this, what's being indicated are probable, most probable, probable maximum, most probable inflow, and probable minimum inflow. So what the Bureau of Reclamation does is it takes certain years and puts this into the recipe and then adds this onto observed conditions. So in terms of the maximum inflow, when they run this out, the maximum inflow that they received based on historical conditions is indicated by this blue curve. By contrast, the probable minimum inflow is indicated by this red curve, and the most probable inflow, which is really in the middle of the samples that they used, is shown here in green. Unfortunately, I think we can probably rule out the probable maximum inflow. Why do I say that? Well, below average precipitation is anticipated in the southwest United States and below average snowpack on April 1st. So this is a pretty unlikely outcome given the forecast conditions that we're expecting over the next 6 to 9 months. On the other hand, these outcomes that are in green and red become more likely because of the expected La Nina situation that is forecast to develop over the next few months. And as a result of that, we're expecting for Lake Powell levels to really be along the lower end of this spectrum right here. And along the lower end of the spectrum would indicate that conditions in Lake Powell levels are lower now than they are, lower in May and June of next year than they are right now. So this again here is the water utilities scenario, and it's a good time to ask if there are any comments or questions from those in attendance.
So here's the hand.
It's all right, Roger. You can just jump right in.
So can you go back one slide?
Sure.
So I think I know the answer to this, but those most probable outcomes take into account the historic 7.5 million acre feet delivered to the low basin.
That's correct.
Okay. Oh, that's what that says.
Yeah. So yeah, I should have said that, but yes, that is
Okay.
what that is.
Okay, I see it now. Okay. So hypothetically, if there was a desire to not send 7.5 million acre feet down, the actual elevation could go up based on the existing or predicted inflows, right?
Yeah, I suppose if they weren't to release any, then they would be 7.5 million acre feet higher
Right.
than they would be here.
Okay.
Well, thank you very much, Roger. Are there any other comments or questions? Okay, well, hearing none, we will move on here to public health, where we've got a multifaceted scenario here. So in Southern California, poor air quality is expected in September to December of 2025 and April to June of 2026 due to smoke from wildfires, and we're highly confident in that. And in March to June of 2026 due to blowing dust, and we have medium confidence in that. The reason why we have medium confidence in that is because wind speeds are pretty difficult to predict at these lead times, despite the fact that the land surface projects to be dry during that period. So the supporting evidence here is that there's an elevated risk of significant wildland fire potential in Southern California through the end of 2025 and the entire Western United States in September of 2025. And in March to June 2026, intermittent high winds blowing over a dry land surface related to below average precipitation during the 2025-2026 wet season. And then finally, below average precipitation and above average temperatures in the 2025-2026 wet season increase the risk of wildfire in 2026. I just want to begin here with the heat. We don't have no indication of heat in this in our scenario because we're being forward-looking here. But we did want to ruminate on this a little bit and reflect over the last few months, where in southeastern California there was upwards of about 2 weeks more of extreme temperatures, those exceeding 37 degrees Celsius, than we have seen in the historical record, or on average in the historical record. By contrast, we actually saw here extreme heat days being below average, which we haven't seen too much of in recent years, but there was quite a bit of onshore flow, thankfully, that did help to cool down temperatures in those areas. Now, recently, air quality index has been deteriorating. Part of the reason for that is because there's been a fair bit of wildfires that have been cropping up in Southern California and more generally in the Western United States. Some of those areas actually include Arizona, and I'll call out Arizona for this reason, where this is not the time of year that Arizona tends to see a lot of wildfire. Their wildfire season is more predominantly springtime, and by this time of year, they've presumably had a decent monsoon that has put out those fires, but unfortunately not to be the case this year. And not only are the wildfires in Southern California locally affecting air quality, there's poor air quality generally throughout the entire United States because of a fair bit of fires that are burning within the greater Western United States region. So that is something to be considered and focus on as we move over into the next few months. This right here is significant wildland fire potential outlooks for September on the left and November on the right. So this is from the National Interagency Fire Center. So the red coloring indicates an above normal significant wildland fire potential. The green coloring indicates a below normal, and normal is indicated by white. So throughout the entire United States, there's only a little area here in northwestern Montana where there's a below normal significant wildland fire potential. By contrast, throughout almost the entire Western United States, there's an above normal wildland fire potential. That's because of prevalent drought across the West that's been persistent for some time. Now, as we move into November of 2025, what you'll note here is that the above normal wildland fire potential decreases in the Pacific Northwest as the wet season in that region really begins in earnest. And also noting here too that La Nina tends to increase the likelihood of above average precipitation, which is why all the red coloring has been removed from the map. Unfortunately for Southern California and our focus here, there's still an above normal significant wildland fire potential in November of 2025. It stands to reason for that. The region's in drought right now, and that the wet season tends to not begin really in earnest until a little bit later on, November and December. And it's really difficult to forget conditions from last year where we really didn't have an onset of the precipitation season in Southern California really until January and February, which led to a further drying of the land surface and, of course, those devastating fires that happened in early calendar year 2025, in January, that is. So it's really difficult to make a forecast like that, as destructive as that, and as consequential as that at this lead time. But if we do reflect on last year, and if it has any lessons learned, if we're learning any lessons this year compared to last year, that is a potential risk and something we do have to look forward to in the context of La Nina. A key predictor of wildland fire potential is vapor pressure deficit. Vapor pressure deficit is really, if you want to put this in air quotes, the thirst of the atmosphere, meaning that if we have a higher vapor pressure deficit, the atmosphere wants to take more moisture from the land surface than it otherwise would. And the vapor pressure deficit is measured by taking into account the maximum amount of water vapor the air can hold compared to how much it's actually holding. So when the difference between the two is very large, then what we tend to get is greater evaporation from the land surface and more wildland fire potential and risk. Well, for forecasts of September, October, November of 2025, what we're noting here is there's an above normal vapor pressure deficit probability to the tune of 40 to 50 to 60 to 70 to 80% here. So unfortunately, it looks like the pump is being primed for significant wildland fire potential risk, based not only just on expert forecasts, but also on the information those experts are using in order to make those forecasts here, and vapor pressure deficit really being a principal indicator of wildland fire. So really, in order to mitigate this risk, the wet season in the Southwest needs to begin, and it needs to begin quickly. But unfortunately, when it comes to La Nina really delays the wet season, and it leads to below average precipitation outcomes, which really can heighten wildland fire risk late in a calendar year. Now, another perspective here that really falls onto what I just said is the chances of below average precipitation and above average temperature related to La Nina during September to November. So I showed this previously, and basically what it's showing here is for September to November, the increased probability of below average precipitation related to La Nina compared to that of non-La Nina. So these brown colors indicate the likelihood or the increased likelihood of below average precipitation related to La Nina. You can see this here throughout almost the entire Southwest in Southern California. And meanwhile, above average temperatures are more likely during La Nina compared to non-La Nina, especially over southeastern California. So an outlook like this, and using our history as a guide here during La Nina events, this is not a good outcome. Now, looking here in December, January, and February, we see more of the same. That is, below average precipitation is more prevalent during La Nina compared to non-La Nina. And this right here is noted here in Southern California, Arizona, and New Mexico, in addition to above average temperatures also being more likely during La Nina compared to non-La Nina. Another thing that we also do want to note here is winds. What's being shown here is the historical distribution of wind speed as a function of time of year. And this begins here in October and then goes all the way through September. What you note here is that there's an opportunity to have really high wind speeds in Southern California, and this is averaged across our entire focus region during April, May, and June. And that really heightens our concerns here for blowing dust and the effects of that blowing dust on public health. We can also see some pretty decent wind speeds later in the calendar year as well. And that right there is not a good situation for wildfire either. And this is really highlighting here some of those localized conditions related to phenomena such as Diablo wind and Santa Ana winds here. So winds really from later in the calendar year, early into the following calendar year, do really play a role in aspects like wildfire, blowing dust, and of course, on human health. So what I'll do is I will finish up here and let the public health scenario sit on the screen while I ask you if you have any comments or questions.
There's a question and a comment in the chat.
So no good news? Yeah, unfortunately, no good news. And Roger asked, how does vapor pressure, I'm going to get to Roger's question, then Jesse, I'll get to yours. So how does vapor pressure deficit play into soil moisture? Well, vapor pressure deficit will rob the land surface and soil moisture of moisture when it's higher compared to when it's lower. So how does it play into soil moisture? Well, higher vapor pressure deficits are bad for soil moisture. And if you want me to expand on that, Roger, I'm happy to, if you have any clarifying questions.
No, I guess it's probably a deeper question dealing with, like, I guess it would also enhance evapotranspiration as well, correct?
Totally. Yes, evapotranspiration really being lumped into that larger category of evaporation.
So all of those areas in that map, turning it to like an agricultural perspective, are going to be needing potentially more irrigation than if they were further on the left end of that scale.
Yeah, absolutely.
Correct. Okay.
Absolutely. Yeah. And you're reading my mind because I think that's the next slide. So Jesse said, helpful to see the blowing dust forecast, especially for an endemic valley like Beaver County. Like, yeah, we're happy to be able to produce that. And I think as we go through the wet season and into the spring, we'll have more targeted forecast and be able to provide more guidance regarding blowing dust as it relates to wind. Alrighty, so we're moving on here to agriculture. And no, sorry, Roger, it's in 2 slides, not the first slide. Crop stress, which may reduce agricultural productivity, is expected through at least spring of 2026 in Southern California due to a second year of below average precipitation and above average temperatures, especially during the dormant season post-harvest. And we have high confidence in that. This first point of supporting evidence is that current low soil moisture in Southern California is forecast to persist, and that below average precipitation and above average temperatures in Southern California are most likely between September 2025 and May of 2026. So rangeland forage production looks like so in Southern California, where prime time is March, April, and May, but there's some marginal contributions during October to February. So we're really looking at the next 6 to 9 months as being really critical in terms of of production for forage like is shown here, but also in terms of like citrus fruits as well. Now getting in here to evaporative demand. So evaporative demand is a quantity that we use in order to also measure the thirst of the atmosphere. Evaporative demand includes vapor pressure deficit, but it more explicitly includes quantities like temperature and quantities like solar radiation. So evaporative demand is a little bit more of an umbrella term and an all-encompassing term, of which vapor pressure deficit, like I showed previously, is a contributor. So what's being shown here is for the past 3 months, evaporative demand has been exceptionally high in Southern California. If you couldn't already note that from the really deep red color that is predominant on this slide. What it shows right here is that evaporative demand was greater than the 90 or 98th percentile, meaning that it was exceptionally high. And that's a result of not only dryness in the atmosphere, but also because of really warm temperatures across the region. So evaporative demand being what it is, what we're getting is a greater desiccation of the land surface and a greater desiccation of soil moisture and a greater desiccation of vegetation than we otherwise would see. Now, it follows that soil moisture is low, and that's a result of low precipitation for the prior 12 months, but also for exceptional evaporative demand. And you're seeing that here throughout the entirety of the Southwest and Southern California. So deeper red colors indicate lower soil moisture percentiles. These deeper greener colors, they indicate higher soil moisture percentiles. And unfortunately, over the Southwest United States, low soil moisture is the dominant feature in that region. Now, when it comes to soil moisture forecasts, our colleagues at the Climate Prediction Center, they take soil moisture like so, and then they force a land surface model with forecast conditions like precipitation and temperature. And then the model that they use is able to give back what the soil moisture forecast would be on January 26th, on January of 2026. And what this is indicating here is that the low soil moisture that is persisting right now in the Southwest is forecast to continue through this 6-month period. And it's unfortunate to see that, but it's a reality of a La Nina and a La Nina forecast. Now, going through this very, very briefly, because I'd shown this previously, but in order to be really complete, we have to show it here. What we're seeing here for September to November is an increased probability of below average precipitation and above average temperatures during La Nina related to compared to non-La Nina. During December to February, an increased chance of below average precipitation during La Nina compared to non-La Nina. Same goes for temperature, whereby we're seeing an increased likelihood of above average temperatures. And then finally for March, April, May, an increased chance of below average precipitation during La Nina compared to non-La Nina. And on the other side, an increased chance of above average temperatures. So unfortunately, it does not look like favorable conditions as we go forward with agriculture, where there is in all likelihood to be agricultural stress without seeing substantial irrigation. And as a result of the below average precipitation, warm temperatures, above average evaporative demand, that would necessitate seeing even more irrigation as we go into this wintertime and the following springtime. So I'll finish up there with the agriculture scenario. Are there any comments or questions?
There's a couple comments in the chat, Andy, just no questions, I don't think.
Yeah, I just saw Jesse's comment. Selfishly a bit excited. It's okay to be selfishly excited sometimes. Okay, well, that is the final slide. And if anybody has any final comments or questions, we'd love to hear them. Having your feedback and your participation is really great. It makes this process worthwhile. And now's a good time to chat, but if you don't feel comfortable in this forum, feel free to email myself and Amanda.